Hi viewers, good morning. Welcome to digital classes. Children, are you ready with your pen and paper? I would like to give you a small problem. Please note down, find the value of 12 into 12. It is very convenient, isn't it? Suppose I ask you to find the value of 103 into 103. Naturally, it takes more time for you to do the calculation. Is there any other way for doing these problems quickly? Yes, of course. We can write 12 as 10 plus 2. Observe the screen. What are the figures formed in the large square? Observe. Here, two squares are formed and also two rectangles. Further, if you observe two squares and two rectangles, what are the sides of the two squares formed? They are one square of side 10 centimeter and the other square is of side 2 centimeter. Also we can observe two rectangles formed here. What are the length and breadth of the two rectangles formed? They are having the dimensions 10 units by 2 units each. What is the total value of large square? Here we can observe that the red square contains 100 square units and the two rectangles contain each 20 square units. Further, the small square which is green in color is of side 2 units and its area is 2 into 2, 4 square units. Even in the screen we can observe the number of small squares. In the red square we can observe 100, in the two yellow rectangles 20 plus 20 and green square 4. So total is 144 square units. So 12 into 12 is equal to 144. The same thing we write it as 10 plus 2 whole square is equal to 10 square plus 2 into 10 into 2 plus 2 square. Likewise, we can write 103 as 100 plus 3. Just observe. Here, it is a line segment of length 100 units and the green line segment is of length 3 units. So, now we observe that a red color square is formed and here its area is 100 into 100, that is 10,000 square units. Likewise, another rectangle is formed here, observe, of length 100 units and breadth 3 units, so it is 300 square units. Again another rectangle is formed here of length 100 units and breadth 3 units, 3 into 100, 300 square units. The last one is a square, of course of each side 3 units. So we can observe that its area is 3 times 3, that is 9 square units. So further what happens, you observe all these values we have to add up. So 10,000 plus 300 plus 300 plus 9, that's how we get 10,609. We can understand that 103 into 103 will give us 10,609. 10 plus 2 whole square is equal to 10 square plus 2 into 10 into 2 plus 2 square. Likewise, we observed 100 plus 3 whole square is equal to 100 square plus 2 into 100 into 3 plus 3 square. From the above examples, we can generalize that a plus b whole square is equal to a square plus 2ab plus b square. We are comfortable in solving the problems using this identity a plus b whole square is equal to a square plus 2ab plus b square. Now, let us verify the algebraic identity a plus b whole square is equal to a square plus 2ab plus b square. Actually, why we have to verify the algebraic identity? We know that learning mathematics is joyful when we understand that, and visualization plays a vital role in increasing this understanding. So, we are taking the help of geometrical figures for getting a better understanding of this. Now, just let us observe the screen. It is a line segment of length A units and another line segment of length B units. So, total length of that line segment is A plus B. It is projected in the opposite dimension, that is along the breadth. It is extended to a length of A plus B units. That's how a square is formed whose area is A plus B whole square. Now, it is A, B, again A, B. Now, we can observe that these are of the same length. A square is formed of whose area is A square. Again, we can observe one rectangle of length A units and breadth B units. Its area is AB. Again, length A and breadth B, that's so we get another rectangle of area AB. Of course, these two rectangles are having the same area, so AB plus AB 2AB, and finally the small square which is having an area of B square because its side is B units. So, the large square is of having side A plus B. So, its area is A plus B into A plus B whole square, and it contains 4 parts. The 4 parts areas are A square, AB, AB, B square. When we add A square plus AB plus AB plus B square, that's how we get A square plus 2AB plus B square. So, here we verified A plus B whole square is equal to A square plus 2AB plus B square. Children, watch this video how the algebraic identity A plus B whole square is equal to A square plus 2AB plus B square is verified through an activity. Okay, we are considering A is equal to 20 units or 20 centimeter and B is equal to 10 centimeter. So, A plus B is 30 centimeter. So, first here we are preparing or making a white square of side 30 centimeter. For making this square, you observe what is the technique we are adopting here. We are folding along the diagonal so that the exact square is formed. Now, you just observe it carefully how the square is formed. Now, for this square, side is 30 centimeter, so its area is 30 whole square. Next, we are considering a red color sheet and we are taking the measurement 20 centimeter on this. Means from this now we are going to take a square of side 20 centimeter. So, again for preparing a square, simply we are folding it along the diagonal of the square. Now, we tear off the extra pieces so that the exact square is left and we are not having any inconvenience with those extra pieces. We are removing the extra portion from that, and with the help of a scale we are tearing off the extra portion. Here we can observe that a red color square is formed. Its side is 20 units and its area is 400 centimeter square. Again we are considering a green color paper. We are preparing a square of side 10 centimeter with this. So again you can observe that whenever a square is formed, we are making it by folding the diagonal. First we measured 10 centimeter, then the extra piece is taken off, then along the diagonal a fold is made such that the two edges are in contact with each other, they are coinciding each other exactly, then the folding is made, and now along the other edge the paper is tear off. That's how we obtained another square which is green in color of side 10 centimeter. Now what else is needed? You observe, we need two rectangles. These two rectangles we require length 20 centimeter and breadth 10 centimeter. Because two rectangles are needed, first we are measuring 20 centimeter and the extra portion is removed. Again we are preparing a square of side 20 centimeter. You observe here, again we are preparing a square. Now for this square, after preparing it, we exactly cut it in the middle so that we can get the two rectangles, because the other two rectangles breadth is 10 and 10, no? So they both together will make 20 centimeter. So we are preparing two rectangles from this square. You observe how we are doing. Then the two rectangular pieces, we can observe that one white square which contains 30 centimeter, one red square 20 centimeter side, and now the red square is arranged of side 20 centimeter on that, and then further you observe. So the side of this red square is 20 centimeter, this rectangle is 20 centimeter by 10 centimeter, again this rectangle is 20 centimeter by 10 centimeter, and of course the small square 10 centimeter by 10 centimeter. So we can observe that the large square 30 centimeter side square is exactly covered with these four parts. So that's how with this activity we verified the a plus b whole square is equal to a square plus 2ab plus b square algebraic identity. Now let us verify the algebraic identity in a more general manner by paper folding. How can we do? Let us see. Take a rectangular sheet of paper, fold it such that the two edges are in contact with each other exactly, then make a crease, then again fold it back, then when you remove this part, we were left with a square sheet of paper. This is a square sheet of paper. Now in this, of any desired measurement, you make a fold like this. In this is A, this is B. So the total length is now A plus B. Again here you can make a folding here. Before this you draw a line along this crease. Now you make a folding here like this so that the two edges are again in contact with each other, and make a crease, and again make another crease along this edge.
can draw a line along this. Now we can observe that again this is A, this is B, A, B, and of course this is A, this is B. Now this is a square of side A, so its area is A square. This is a rectangle of length A, breadth B, so its area is AB. Then again this is a rectangle of length A, breadth B, so it is AB. And this is a square of side B, so its area is B square. So this total area is A square plus AB plus AB 2AB plus B square. So A square plus 2AB plus B square. Now if we observe this sheet, this is A, this is B, so total length is A plus B. Likewise here this is A, this is B, so total length is A plus B. So this is a square of side A plus B. So its area is A plus B into A plus B, that is A plus B whole square. We can observe that the area of this total square, that is A plus B whole square, is equal to A square plus 2AB plus B square. That's how we verified A plus B whole square is equal to A square plus 2AB plus B square through this paper folding.
Okay children, you observed that here A plus B whole square is equal to A square plus 2AB plus B square identity is verified. Now let us solve some problems using this algebraic identity. A plus B whole square is equal to A square plus 2AB plus B square. Expand 2x plus 3y whole square. So you can observe a line segment of length x, another line segment of length x, so 2x, and 3 line segments y plus y plus y. That's how we get 2x plus 3y. Likewise, when the 2x plus 3y line is projected vertically or along the breadth, again we can observe x plus x plus y plus y plus y. So here again we are getting 2x plus 3y. So we are considering a line segment of length 2x plus 3y and it is projected in the downward direction, and because of this we are getting some rectangles and squares. We are going to observe them one by one. Here at each and every line segment of length y, a line of length 2x plus 3y is drawn. That is what we can observe here. Again, vertically also, when we draw these line segments 2x plus 3y, they are all having the same length. On the screen you can observe the formation of some squares and rectangles. Dear children, observe keenly how many squares are formed, how many rectangles are formed, of what color they are formed. All these things you have to observe. Here, for representing the line segment x, we considered red colored lines, and for representing y, we are taking yellow colored lines, right? Now we are getting squares. How many squares are formed? First, with line segment x, we have 4 squares, and yellow colored squares you can observe 9 squares are formed. Likewise, you also observe the number of rectangles formed. So 6 rectangles are formed at the bottom and 6 rectangles are formed at the top. So we can observe that 4x square plus 6xy plus 6xy plus 9y square. So it is 4x square plus 12xy plus 9y square. Now one more problem. Find the value of 2.5 whole square plus 2.5 plus 0.25. How do we solve this? Is it possible for us to do the calculations quickly? We can solve this problem very easily and comfortably using the algebraic identity. Let us see. We can write it as 2.5 whole square plus 2 into 2.5 into 0.5 plus 0.5 whole square. Of course, children, till now we are saying every time that a plus b whole square is equal to a square plus 2ab plus b square. But is equal to sign is there means both are equivalent. So, even we can say that a square plus 2ab plus b square is equal to a plus b whole square. Now, we are using the formula from the other end. Observe. So, 2.5 whole square plus 2 into 2.5 into 0.5 plus 0.5 whole square can be simply written as 2.5 plus 0.5 whole square, that is 3 whole square, that is 9. Now, here we are going to give you some questions for extensive learning. Write down. Simplify 2.5 into 2.5 plus 2 into 2.5 into 1.5 plus 1.5 into 1.5 whole divided by 4. Once again I repeat, simplify 2.5 into 2.5 plus 2 into 2.5 into 1.5 plus 1.5 into 1.5 whole divided by 4. And next problem, if a plus b whole square is equal to a square plus b square, then find the possible values of a and b. Once again I repeat, if a plus b whole square is equal to a square plus b square, then find the possible values of a and b. Next problem, you just observe the screen, children. Simplify 2x plus 3y whole square plus 2x plus 3y into 2x minus y plus x minus 2y whole square. Once again I am repeating the problem, listen carefully. Simplify 2x plus 3y whole square plus 2x plus 3y into 2x minus y plus x minus 2y whole square. Next one, if a is equal to b, then find the number of terms in the expansion of a plus b whole square. Next question, it is related to the day-to-day life. A person constructed a house exactly in the center of a square plot, leaving a uniform width of land all around it for gardening. Write an expression for the area of square plot in terms of its width. Once again I read the question, note down carefully. A person constructed a house exactly in the center of a square plot, leaving a uniform width of land all around it for gardening. Write an expression for the area of square plot in terms of its width. Dear children, not only this, I would like to give you a small group activity. Now observe. Here already you have seen one paper activity, the way in which the squares are cut and arranged for verifying. Now what you have to do is take any two values for a and b. Here in our paper activity we considered a is equal to 20 centimeter and b is equal to 10 centimeter, and white square we took 30 centimeter. That's how we verified. Likewise, you select two values for a and b and verify the algebraic identity. Okay children, till now we discussed the algebraic identity a plus b whole square is equal to a plus b whole square is equal to a square plus 2ab plus b square. We verified it by paper folding as well as one activity. Even we gave you some problems for extensive learning. What you are supposed to do is you try to solve the problems and don't forget to take the help of your teacher for solving these problems. Okay? Thank you, children.